So it was a very good talk by Darren. I hope all of you in this room enjoyed the talk. It was quite a lot for me about LLM, agent, and auto completion of the code. It was quite huge, and hope you guys enjoyed the session. Let's give it up a huge round of applause once again for Darren for his great presentation from Microsoft. So, well, who am I? I'm from London. Basically, my origin is from India. So my journey towards till here in Izmir, like while I was traveling in the flight, I met a lot of co-passengers, and they were trying to share me about what's the culture, what's the history of Izmir, and I had a different, I was guessing like how the crowd might be and how the city might be. And to be honest with you guys, you are so crazy, and the amount of energy that you're showing to the event is awesome. And thanks for all the support, be it as an audience or be it as a speaker. You're trying to help and trying to learn from others. The willingness to learn and willingness to share is huge. And what I would say is this kind of a support is what really the organizing team is looking for, because I myself, being an organizer in London for DevFest events, this is a kind of a motivation that we take when we keep on doing these events consecutively, and that's one of the key factor. So coming to today's topic, so why I'm here, what topic I'm going to speak, let's discuss about more in detail. So the topic is serverless workflows on Google Cloud. When I say Google Cloud, I'm mainly focusing on two more of the technologies. One is Cloud Composer and other one is Cloud Function. So just I wanted to understand, like just a show hands, how many of you in this room have used Google Cloud or been using Google Cloud? Great, that's a good number. How about the Composer and Cloud Function? How many of you used Cloud Function, Composer? Good, it's very good. Okay, so let's see if I can add more to the topic so that you guys might get some insightful information from this. So just a quick introduction about me. So I'm Santosh Perumal. I'm based out of London. I have around 10 years of IT experience. I work for Tata Consulting Company. So it's mostly my journey towards all towards is on the banking and financial sectors. I play a cloud and DevOps engineer role. I help organizations to migrate to cloud and adopt open source tools. So I'm also passionate about community and community engagement, and that's one of the reasons why I'm today here. When I say I'm passionate about community, because of this I was able to get involved in a lot of good community programs. One of the notable programs is Google Developer Expert. So for those who are not aware about what is Google Developer Expert, it's a volunteering program where a set of people help and highlight the benefits of Google technologies. It is a diverse program. It is not just for one of the Google technology. Let's say Google has a lot of technologies like Google Cloud, Flutter. So every category has their own GDEs, which they call as developer experts, and they try and share knowledge across the ecosystem. So I'm quite happy that I'm part of GDE Google Cloud. And the other things to mention, as I mentioned earlier, I'm also volunteering and organizing DevFest and also speaking at different forums. Recently I spoke at Istanbul DevFest last month, and it's quite happy to come again here in a different city. And some of my other achievements to community involvement is I'm also part of CNCF. When I say CNCF, it is called as Cloud Native Computing Foundation. So it is a foundation which takes care of a lot of open source tools. When I say open source tools, it is one of the common or one of the major open source project CNCF takes care of is Kubernetes, and there are a couple of other open source tools like OpenTelemetry and couple of other platforms. So being part of this organization, I'm also helping them to conduct events and speak at their forums. Some of the notable talks where I have featured are like Kubernetes Community Day. It's a program mainly focusing on Kubernetes, and we also hosted our first meetup, which is a sustainability event meetup in London this year. So these are some of my community engagements, and I would also encourage all of you who are not part of this kind of community programs, try to join as a member, and then try to see opportunities where you can join as an organizer or volunteer and try to understand how things are, how the community ecosystem is growing. So that's a quick background about myself. So before starting the session, let's start with a well-known quote by Paul, where it goes like this: cloud is about how you do computing, not where you do computing. So this quote, we are going to see in our future slides how this quote is going to relate, and how the slides will help you to relate to this quote. So what we are going to see now is, what is serverless computing? So even before going to what is serverless computing, let's take a step back and try and understand where were we 10 years back and where are we now. So we started with on-premises, where we had the data center in the organization, and we had to manage the rack servers, and the rack servers were connected with multiple cables, and you had to have a dedicated team who takes care of the whole data center and keeps it highly secure, reliable. And why did we move from data center, or why did we took the model of hybrid? So that's the main thing that we need to think about. So owning a data center and managing for an organization, for a small organization, is an easy job, but if the organization is growing rapidly, or if it is not doing well, it has to cut down the infrastructure, or it has to increase the infrastructure. Managing infrastructure is not an easy job. You have to procure the infrastructure. You'll have to make sure that it is matching the demand of the user. You're not overpaying to the infrastructure, or you're not wasting the infrastructure. So it's quite difficult to predict this. So what we did, we thought of moving to a renting model. So a renting model is where you, instead of you managing the server, rather than saying managing, instead of you having the servers in your data center, you go for a renting model with the cloud providers, and you say that I rent for a given number of time and I just pay for that duration, instead of having the whole data center or having the whole service in my data center. So things were all fine here. We were able to address some of the problems which we spoke before, which the problems that we had in the data center model, but still there were few challenges here. So what were the challenges that we had in the approach of renting? So though we took some of the burden and we gave it to the cloud provider, still there were few things that we were repeatedly doing. Some of the key points that I would say that gave a thought to the company to think about something more rather than just renting the server is, they'll have to manage the servers, they have to upgrade the operating system, they have to patch the operating system, they need to make sure that everything related to the infrastructure is in tight. So that was a huge challenge. So that's where organizations thought, why can't I also take this off from my burden, and so that I can build better products and I can also build better applications. So that's where the concept of serverless came into picture. So in serverless model, what you say, it's a computing model wherein you don't manage the server. Though the term says that serverless, it doesn't mean that there is no server. There is still server, but the second aspect that I mentioned, managing the servers, is no more it's not your burden anymore. It's taken care by the vendor. So having said that, what is serverless and why we moved to serverless, and we can also talk about some of the advantages of serverless. It is not just managing the server, there are quite a lot of other advantages as well. So when I say quite a lot of other advantages, one of them is auto scaling. So as all of you know, having a persistent cluster, it's like you keep paying whether no matter you have a traffic or you don't have a traffic. But having something that where there is no user request, at that time you don't pay anything to the provider. When I say you don't pay anything, there is still cost where it is not related to compute, but at least in terms of compute, you don't pay anything to the vendor when there is no request, if you have mentioned that it should scale to 0. When I say it should scale to 0, think of an application and there are a lot of users coming in and hitting your application, and during the let's say during the night time there is no traffic to your retail application. So during that time you can have some of the services, not a bigger application. You cannot put a whole retail application, or you cannot bundle a big application into your serverless platform, because serverless platform is not designed to have that kind of a huge application. You'll have to make sure that you are fitting in the right use case. It should be a lightweight application that handles without having so much of dependencies. So what happened here? We were able to auto scale, and we were also in a position that we were just paying what we were using instead of having a persistent cluster. So that is one of the advantage that I would say, having serverless computing. Having discussing about serverless computing, now you might be thinking about what are the vendors that are offering serverless computing. So I'm sure there are a lot of other vendors, but I just listed some of the well-known vendors. So starting with Google Cloud. Google Cloud has couple of serverless computing offerings, but I'm just concentrating on Cloud Functions. So we'll go deep dive into Cloud Functions, what it is, and we have another offering from Azure which they call as Azure Functions. They both, like all these three, are more or less same, just the naming convention and the approach that they follow, and it's from different vendors. And we have AWS, we have Lambda Functions. So you might have been thinking like, what is FAS? F-A-A-S. So FAS stands for Function as a Service. So we have a lot of services like Platform as a Service, Infrastructure as a Service, Container as a Service, Function as a Service. So what is basically Function as a Service is, you are trying to write a function which is not too big, a smaller function which can be helping you to address couple of use cases, like scanning through your file in your cloud storage and trying to find out the malware or the viruses in your file and trying to scan through, or trying to upload your file from your cloud storage or your bucket based on some data, and it kind of cleans up the bucket. So it can be any kind of this activity, or generating an invoice or generating a payslip. So this kind of smaller functions can be written, and because of writing this kind of a function, it is easy for the underlying infrastructure to handle instead of you bundling a bigger application. So though these three vendors, or most of the vendors implementing serverless computing, you'll have to understand behind the scene it is working on an open source software called, or open source project called Knative. So Knative is an open source project which is mainly working on the concept of CRD, so Kubernetes resource definitions, wherein it uses that model. All the vendors are using that model, and using that model or using that framework, they are giving you these offerings. Then you might be thinking that is there any vendor lock-in situation because of using this kind of framework? So definitely there is no vendor lock-in situation, because they have made that clear. There should not be any vendor lock. It is all open source OCI related. So when I say OCI, Open Container Initiative, so you write your code as a function using multiple programming languages. It can be Python, it can be Node.js, it can be Go. Google supports multiple programming languages like Go, Python, Node.js, Java as a function. And if you don't like Google Cloud Function, you don't need to change your code. You can simply move to either Azure Functions or Lambda Functions. So that is the kind of portability that every cloud providers are providing in terms of fast or in terms of serverless computing. And the whole idea or why it is possible is because of using Knative. So you can check more about what is Knative project if you go to CNCF landscape. Just type in CNCF Knative, it will take you to a bigger landscape wherein you can see multiple projects which I mentioned, like Kubernetes, OpenTelemetry, and one of them is Knative, and just see and understand like how the community is contributing there and how the maintainers are managing the code, and see how these providers are trying to use that project and trying to build this kind of offerings. So now that we understood what is serverless computing, and we saw how did we evolve from the on-premise data center, and we saw the advantages of serverless computing, some of the offerings. Now let's narrow down our discussion to cloud functions. So cloud function is one of the key offering which we just saw in the previous slide. So this cloud function is mainly for, as I said, running a lightweight functions. So when I say running lightweight functions, it can be any programming language that it is supported by Google Cloud. And why we use this is, basically it is used for two kind of approach. One, it can be for triggering based on your HTTP. So when I say HTTP request, it can be post, it can be get. So you can use any kind of this request, and if you make a trigger based on that request, the cloud function can be triggered. So the other way to trigger cloud function can be for any of the event driven. Let's say you have a cloud storage, which is a bucket. Let's think of a bucket where you store all your files, and you want to trigger a function whenever you upload a file to the bucket, and that is an event within the Google Cloud. You're trying to upload something to Google Cloud's storage, which is cloud storage, and as soon as that event happens, you need to trigger the cloud function. So it can be also use it to trigger based on an event. Not that, just like you can also use cloud function to do an API call. Let's say you have a big use case wherein you have a request coming in from the publishers. The publishers are publishing the data. Let's say it might be in a different format, let's say it is in JSON format, and the cloud function reads that, and you want to convert the JSON format into a 2D format, and you want to put it in the database. So whenever a request comes to the cloud function, it triggers, and in order to convert it, there has to be multiple things that has to happen, wherein you can be using multiple platforms, wherein you can be using a cloud composer, since it is a data pipeline orchestration setup, or you can be using a Spark or a Hadoop ecosystem like Dataproc, or you can be using multiple other data related service within Google Cloud. It can be BigQuery, wherein you want to do some kind of insight analysis on your data. So having this kind of a setup, you can integrate cloud function easily wherever it is required. As I said, you need to make sure that the use case are very clear and it is not used in a wrong use case. So that is one of the key use case which I would highlight. So to go more deep into different use cases, let's take here which I mentioned, we have a cloud storage which triggers the cloud function. Let's say it is based on a file, you upload something on the storage bucket, and because of the file upload, it triggers a cloud function. And what logic you have in this cloud function is, it processes the uploaded image, and what it is processing is, like, it is also calling another API. All the offerings within the cloud are nothing but the APIs. So it calls a Cloud Vision API, which actually detects offensive images, and again this Cloud Vision API will call a cloud function which kind of blurs the offensive images and then uploads the fresh image to the cloud storage. So this is one of the use case that you can think about, and there are a lot of use cases like this. If you go to Google Cloud documentation, which is the golden repository to understand more about the Google offerings, and as I said, the data processing or the ETL is the major use case. extract, transform, and load. You extract something and you transform it based on the business requirement, and then you again load to the database. Or it can be based on the webhook, which I told, based on the HTTP request. Or, and also it is mainly for the lightweighted application. So you need to keep those things in mind. And it also has support to IoT and mobile backends. So having discussing about cloud functions and their use cases, let's discuss about some of the recent trends in serverless. So if you could see the graph, you have different sectors like IT and telecom, and BFSI as well as retail. The market share or the trend says that serverless architecture market size is projected to surpass $90 billion by 2032. So this is according to a recent research report. And if you could see the way how BFSI and retail are slowly growing over a period of time, and I myself working for multiple BFSI clients, I can see that the banking sectors are not thinking too much about it, like how they were thinking before. Going to cloud might not be safe, might not be secure, but that is not there anymore. They are taking all those brave decisions with all the guidelines and governance, and they're making sure that they are using the best product and best offering. So you can easily predict that by this graph. So let's discuss about Cloud Composer. I don't think so we can go too deep on Cloud Composer because it's a very big topic. So I should not be covering that since it is a short session. Let's give a high level overview of what is Cloud Composer. So Cloud Composer is nothing but it's a managed service for an open source project which is called as Apache Airflow. And Airflow is an open source project managed by Apache, and mainly it is used for data pipelines, orchestrating your data pipelines. When I say orchestrating your data pipelines, like your data pipelines might have multiple systems, as I mentioned, like a Spark system or a Hadoop ecosystem. So you'll have to have an orchestrator who can orchestrate this dynamic nature. And Airflow is being one of the widely adopted orchestration tool. And the pain of having Airflow is like the setup of Airflow is not that easy. You have a lot of components like the worker, you have the executor, and you have the database. Having this manually setting up is a huge task, and that's why Google is coming up with a managed service called Cloud Composer, which is a managed service for Airflow. And the reason why I'm bridging Composer here with Cloud Function is because of one of the use case that I related, wherein you have a Cloud Function which triggers a Cloud Composer, and that further triggers a data proc or any other data processing pipeline like a BigQuery. And all the scripts that goes within the Airflow is a Python script. You write the orchestration logic within the Python script, and they call it as DAG. When I say DAG, it is directed acyclic graph. And because of this Python script, the composer will be able to understand what is your rules and regulations that you need to perform during your pipeline. So this is a high level overview about how composer environment will look like. So it has many components which I mentioned, like Airflow worker, composer agent, and it has FluentD for forwarding the log, and it has Airflow monitoring. Also, if you see web server, that is one of the major component where you interact with web server in order to see how your DAGs are performing, whether your DAGs are failing or it is success. Then many other details can be seen using the web server. If you see, all these components are integrated together in one offering called Composer. So that's the main advantage of having Cloud Composer. I'll just see if I can show you a simple cloud function. So this is Google Cloud Console, and the thing that we were discussing about the cloud function. So this is how you come here, you say cloud function and you say create function. When you say create function, you will see the environments here. So basically cloud function has two environments, Gen 1 and Gen 2. Gen 2 is recently named as Cloud Run Functions. but basically you can think about it as cloud function for now. So then you give the function name and you select the region and you select what is the type to trigger, whether it is a HTTP trigger or whether it is other events, like it can be a PubSub or a cloud storage or many other triggers. And once you select, you will be also seeing different options where you mention what is the memory allocated or how much CPU you need to give, the concurrency, whether you need to scale down to 0 in case there is no traffic, what is the maximum instances that you need to scale in case there is more traffic. Once you select all this, then you will be deploying the function. Before deploying, you will be writing the code. This is what I mentioned, like you'll be selecting the programming language, either Java, Python or Node, and you write your code here in the inline editor. It's not necessary that you need to write the code only here. You can write it separately and you can store that in a Google Cloud Storage and you can refer that to the cloud function. But let's see, just for an example, how this gets deployed. So since it's going to take some time, what I did, I already created a function. Let me show you a function which is already running. So this is the function which is called as Python function here. So if you click on this function, and if you see here, it has different concepts like metrics, details, source, and this is the code that we have written, and variables. And it gives a URL for me, and I just copy this URL, and when you paste this URL in the browser, you are basically doing a HTTP trigger. So because of this request, the cloud function that was written was able to trigger and it was able to give the output. So that's a quick overview about how you can create a cloud function from Google Cloud. So just sharing some of the useful resources that you can go through in case if you are going to start with this journey. So if you're a new person to Google Cloud, I would say start with something called as Cloud Skill Boost. So Cloud Skill Boost is a kind of a platform where it gives you self-paced learning, wherein you can do a lot of demos and you can try it out in your own machine, and you can also see a lot of videos posted by Google so that you can understand the concept more better. That is one of the key resources that I would say if someone is starting their journey. And the other one is Google Code Labs. So in case if you are interested to understand some of the different scenarios that they are using in the industry, you can simply go and visit Google Code Labs. It is a graphical user interface wherein it will help you to understand how to click each and every options in order to create a function or in order to create a composer. So it will give you in a UI. It is very easy for you to understand. Then the last one is Cloud Free Tier. So in case if you are trying to further extend your knowledge, not by just doing small demos, you want to extend your knowledge to do a full tier application. When I say it can be a 3-tier application, end-to-end application, it is quite challenging to use things like Cloud Skill Boost or Code Labs because it is very limited, and after that limited time you will not be able to try it again. So that's where the free tier account will come into picture. Like they give you around $300 credit for around 90 or 60 days, I guess. So it is easy for you to at least try some end-to-end project. That way you get more understanding. So if in case if anyone is trying to do some certifications, I'm sure there are a lot of students here in this room. Having a certification will really help them to get into a specific IT roles, and that is a kind of confidence that someone gets whoever is hiring, that they are already aware of the concept and they are certified. So if you are looking for certification and if you are starting, cloud engineering is one of the I would say basic certification. Earlier it was called as association or associate cloud engineer. They used to call ACE, but now they have renamed it as cloud engineer. So that is the first level certification anyone has to do if they are starting their journey in Google Cloud. And if they are focusing more on data, or if they are trying to be on data engineering role, I would say they can start with associate data practitioner. This is still in the beta phase, but I think sooner they will be going to release this. So this will help you to understand how to analyze your data, how to build a data pipeline, and lot more things about like how to solve business use cases related to data engineering. And if you are a kind of a person who wanted to further extend your data practitioner knowledge to the next level and seek for roles like data engineering, they have professional certification which is mainly for data engineers. They try to help address to understand concepts like BigQuery and many other concepts related to data engineering. So that is the final professional level, but they have similar other certifications for different roles. When I say different roles, as a developer, you might be building a lot of applications, web applications, or you might be writing functions. So if that is the case, you are a core developer, then you can start with cloud developer certification. That is one of the good certification for a developer role. Yeah, so having said this, I'm going to end my session. Thanks for all of you for joining and making this event so good. And it was so happy for me to share my valuable insights with you. And I would like to be connected with all of you guys. And this is my LinkedIn. Feel free to reach out to me. Any kind of queries or any kind of concerns that you want to highlight. I'm happy to learn from you guys, because I know it's people are here like with huge knowledge. While I was speaking to a lot of people, I came to know that there is a lot of things that I need to learn. So I'm happy to learn from you guys, and also happy to share whatever I know. So please be connected with me, and this is my LinkedIn handle. Yeah, thank you. Thanks a lot.